Hello everyone and welcome to Trina Solar Stand. My name is Nasir Khan and I am the sales manager for Trina Solar utility scale projects. So here in this WFES we are displaying our 7 modules and with different type of application for utility scale projects as well as for residential and CNI projects. So let me give you a tour of our modules. So here we have our 410 watt module. This is called Vertex S. It is from our Vertex series of modules. And then moving over further, this one is a 465 watt module. It is from our Tallmax range. And then finally we have this module also from the Vertex series of module. It has a highest power bin of 510 watt and high efficiency of 21.2%. So now let me show you our modules for utility scale projects. Let us move there. Now on this side we have got modules that are basically designed for utility scale projects or for large installation. So starting on with our module of 605 watt. This is our DE20 module. It has the highest power bin of 605 watt. Moving forward, here we have this one is our 555 watt module. It is available both in monofacial as well as bifacial versions. And this module here is 670 watt module. This is currently the largest power bin that our customers can find in the market. It is high on power and it has a high efficiency, 21.6%. It is also from the same Vertex series of module. And with this module we have already gone into mass production. The production started in end of Q3. We have started taking orders for this module. And then this is our latest product. It can be called that it is still in development stage and we are still working on the certifications. But we are expecting that this product would be launched in mass production by Q1 2020, Q1 of this year, 2022. This is an N-type module from the Vertex series, and it will have a highest power bin of around 690 watt. This would be the highest power bin that the market would have seen. And please mind you that all these modules are from Vertex series of modules, from our Vertex family. And when I say Vertex family of modules, what I mean that we are using 4 key innovative technologies. First of all, we are using a big cell size of 210 mm dimension. Then while cutting the modules, while cutting these cells, because all these modules here for utility that we are using for utility scales are half cut cells. So we are using non-destructive cutting to cut our modules. By non-destructive cutting, what I mean is that while cutting our cells in half, we are basically cutting at a very low temperature. So by using this technique, we have our cut cells with very smooth edges without any risk of micro cracks. So the mechanical performance of the cell increases drastically. It is almost similar to a full cell. And then we have high density interconnection. That means we are using an optimum gap of 0.5 mm. All the modules other than the Tallmax that we have displayed in this exhibition in WFES are from our Vertex family of modules. When I say Vertex family of modules, we mean that we are using basically 4 key technologies. Let me show you on the module. So here we have a large cell. This one single cell is of 210 mm dimensions. So this is currently the largest and most advanced cell technology available in the market. And as you can see from this cell, that this is half cut. So basically while cutting the cell, we are using a technology called non-destructive cutting. So this is not the traditional method of cutting the cell, but we are using we are cutting our cells at very low temperature, which eliminates the risk of micro cracks in our modules and making our cell more reliable. Then we have another technique. Then what makes our module really efficient is high density interconnection. As you can see over here, that while connecting the cells, we are keeping an optimum gap of 0.5 mm. So with that optimum gap, we can increase the efficiency of our modules and we eliminate the risk of micro cracks again with some of the vendors using a connection method called shingling. With singling, basically what we have is one cell on top of the other, so which creates unnecessary stress on the lower cell and again increasing the risk of micro cracks. The final technology that we are using is multiple bus bar. So in all our modules, we have 12 bus bar. So when you have more number of 12 number of bus bar, we can really shorten our current path. So we can shorten our current path, and while connecting these bus bar, we use round ribbons instead of flat ribbons. So we increase when the ribbons are rounder, so we increase the optical performance, and there is no shading. So with all these factors involved, with all these 4 technologies, we have drastically increased our efficiency, and now we are standing at a high efficiency, as you can see, of 21.6% for our models.